Contrary to our natural intuitions, we don't experience the world directly. However, our minds simulate the world around us in a virtual 3D space termed the default space. The term default indicates that the external world is defaulted into the internal world. The thalamus is the functional hub which coordinates the bioelectric oscillatory architecture responsible for the default space among not only the cortex but all sensory organs. This bioelectric architecture is revealed most commonly in the EEG, or electroencephalogram. The existence of this virtual 3D space is best revealed in the mental condition known as contralateral neglect syndrome. In this condition, one entire half of a patient's conscious space is eliminated. This recreation takes up the majority of brain activity and energy to maintain. This simulation we experience is more influenced by our expectations, predictions, and understandings of the world than actual sensory stimuli. Therefore, this internal reconstruction is more of a best guess of the external world than what is actually there. Illusions such as the rubber hand illusion reveal we don't see the world as it truly is. However, we see our own subjective recreations of it. By simulating the world, we can simultaneously identify and map our environment as well as our relationship to it, providing a key survival mechanism. Although it may seem that we directly perceive the world instantly, there is actually a lag between what happens in the external environment and when we perceive it, around 80 milliseconds. Regardless, this is still incredibly fast perceptual processing. Of the massive amount of information and stimuli bombarding our senses continuously, how do we so quickly perceive a unified version of it all? One way is to discard irrelevant stimuli, with around 99% of information being discarded before it enters conscious awareness. Via top-down understandings and expectations of the world, we can predict what stimuli will hit our sensory receptors, and thus the stimuli can simply fall into place into our continual, spatially based simulation of the world. These neurological top-down predictions may extend to the sensory receptors themselves. In this way, different senses can help us predict incoming stimuli from other sensory modalities. The binding problem is the mystery of how the many processes of the brain combine into one experience. For instance, when you cross the street, the vastly different visual and auditory cues combine to allow you to predict the location of cars and safely cross the street. Modern research has shown that distributed parts of the brain synchronize together via oscillations, and in this way they may bind their respective processes together into one coherent representation. This synchrony also enhances important activity and discards unimportant activity related to the task at hand. Neurons that respond to the same external objects fire in synchrony, while those that process unrelated stimuli lack this synchrony. A key component in this global process is metastability, in which individual neural modules carry out their own processes while still being harmonized with a global activity. 100 million photoreceptors are harmonized with global processing to create the internal visual space. Despite its familiarity to us all, we still do not know exactly the physiological and psychological basis of why we need to sleep to survive. Enough sleep is crucial to health. However, sleeping too much is also linked to health problems. Multiple functions of sleep have been proposed, such as restoration via the removal of metabolic waste products, memory consolidation, and even energy conservation during dark nights. Dreams may provide the psychological benefit of simulating dangerous situations we would not get a chance to practice escaping from in normal life, but of which practice would benefit us greatly if such a situation occurred, such as escaping from an angry bear. An overlooked homeostatic and restorative mechanism of sleep is the calming of overly excitable neurons. This occurs through global hyperpolarization of the neuron's membrane potential. Sleep may also calm overly aroused autonomic nervous systems. These effects occur via the recharging or increasing voltage of the membrane potential of neuronal and bodily cells. Although consciousness arises from globally synchronized activity across various parts of the mind and body, there still must be a functional hub which orchestrates all of this activity. Indeed, the thalamus is this hub due to its dense, diverse, and heavily networked connections with not only the brain, but the body. All sensory information passes through the thalamus on the way to the brain, and then from the brain back to the sensory receptors. In this way, it is a mini-map of the body and brain, coordinating activity from all over. The thalamus may be understood to act functionally as a metaphorical observer, as it can see the vast bioelectric activity occurring throughout the body and brain. Conscious experience can be characterized as one being the center of an externalized space. This center is actually the thalamus, providing topography between conscious experience and the physiological functional foundation of the thalamus in consciousness. Most consciousness theories describe a brain-centric view in which consciousness arises solely from processes in the brain. However, they have ignored the possibility of the body being included in this process. Cardiorespiratory oscillations are fundamental to the low-frequency bioelectric oscillations of the unconscious mind, which underlie the high-frequency oscillations of consciousness. Thus, cardiorespiratory activity underlies and modulates mental activity. Respiration drives electrical oscillations throughout the brain and body. Via synchrony among the sensory receptors and the cortex, sensory stimuli and sensory consciousness can be represented neurophysiologically, not in complex mental representation, but in the highest topographical form, the sensory receptors themselves. Photoreceptors are pre-calibrated to receive certain visual stimuli. Additionally, top-down predictions and expectations can form actual stimuli on the receptors and influence stimuli reception. Due to the body being so involved in consciousness, voluntary modulation of bodily functions such as breathing can directly affect the phenomenology of the mind. Impulsive mental conditions and uncontrollable emotional outbursts and disorders such as anger, depression, and anxiety cause a great deal of suffering across the world and can also cause physical health problems such as heart disease. A person known as the Iceman has shown the power of mind-body techniques in part through his success in bearing extreme conditions, once climbing Mount Everest in nothing but his shorts. In modern times, due to something termed evolutionary mismatch, our autonomic nervous systems are stuck in overdrive due in part to continual distress caused by our tendency to commit ourselves to goals and responsibilities we can't reasonably achieve. Mind-body interventions are key in calming the autonomic nervous system as well as brain components of negative emotions. These interventions may include meditation, breathing techniques, yoga, and exercise. By modifying one's afferent signals via these techniques, the nervous system can be modified in a way that regulates emotion. States of the mind not only affect the body, but states of the body can affect the mind. For instance, forced smiling and laughter actually improve mood. Emotions are characterized by distinct bodily sensations which are culturally universal, reported by people across the world. These sensations underlie our conscious emotional experiences. Knowledge of the mind-body response and of the nature of consciousness is a powerful tool to foster well-being. For more information, check out the links in the video description.